Okay, so if we have a sketch here of a pretty generic function, so this is an f of x function, this is starting point. What I want to do is do a couple different translations. So I've got the original here, right, sort of goes up and over and then down. We're just sort of ending it here at the endpoints. You could just as easily sort of graph these if this was a function that sort of continued off to infinity. I'm just going to work with this one if we have sort of nice ending points, just to sort of have that as a reference. I think it'll make it a little bit easier for us to get started. So this is our original f of x. What I'm going to do is I'm going to graph, I think, kind of one shift on the same axis, and then I'll maybe do two more over here. I don't want them to be sort of totally stacked over top of each other. It gets a little bit messy to see if we try to do sort of too much. As we go through this, we'll maybe look at this a little bit kind of point to point, but we can also essentially just shift it visually. So if this is our f, let's do, as a sort of a first example, let's just do something pretty straightforward. Let's do f of x, and let's do minus 3 on the outside. So this shift, right, this is sort of our f of x that's here. That's sort of our starting point. And we're subtracting 3 from the end. If we think back to sort of all the different options from the other page, what we're going to see is this should shift us down by 3 units. And so literally all we're going to do to sort of make that change is I'm essentially just going to go point by point, and I'm just going to transpose them down 3 units. So I'll keep the x values the same, and I'll just bring everything down. I'll start over here, so I'm not writing over top of myself right away. So this is, I'm going to take all my y values, and I'm just going to subtract 3. So this, that used to be, right, sort of x is 3, the y is minus 2. I'm going to take it, I'm just going to shift 1, 2, 3 down, and then I'll mark that same point. I'll take maybe this next one, so here at the axis, 1, 2, 3 down, sort of mark that here. This guy, 1, 2, 3 down, we'll mark it. So we can sort of start with, right, this straight line segment, and so this is everything shifted down 3 units. We'll fill in the blanks here, so obviously then this particular corner is going to go 1, 2, 3 down, and it's going to end up here. We're going to run into my writing a little bit, 1, 2, 3 down, sort of end up there right at the S on units, but that's okay. Connect these dots as best we can, and we'll fill it in. And so that green guy is going to be our new function. So that's our function translated down 3 units, f of x, right, minus 3 on the outside. Let's do a second shift, and let's actually combine 2 of these things together. So how about, what should we do? Let's do, the negative version of f of x. Let's do plus 2. So the negative version of f of x plus 2. So write the quantity x plus 2 in our parentheses. So there's 2 different things happening. 1, 2. There's the negative out in front, right? So this negative is going to be a reflection. Negative sign out in front is going to affect our y values, and so that's going to be a reflection over the x axis. So that's part of what we're doing. The other part, right, is our sort of x plus 2 in parentheses, right, on the inside. And so what that does is that's going to shift us 2 to the left. So we're going to go left by 2 units. And so we're going to do these things both. And I think what we'll do is we'll actually, let's do the shift left first. We'll do a sort of inside out order of operations. So if I take, what should I kind of start with as a reference point? Maybe this corner. So that would be here, right? So what I'm going to do is I'm going to shift left by 2 units. So 1, 2 to the left would kind of place me here, right? So this is sort of x is -1, the y is 2. And then I'm going to reflect that over the x axis. So I'm going to reflect it and flip it down to here, right? So our sort of x value used to be here. It goes 2 to the left, and then it flips down to this -2 instead. If I sort of match that, right, let's start with this point over here. So this is, right, x is 3 and the y value is -2. 1, 2, 3, -2. So we're starting there. 2 to the left, so 2 to the left, and then we'll flip, in this case, back up the other direction to there. And in theory, right, these should connect between these two. So we're going to kind of match that movement. We have as sort of an in-between point, one that's now going through the origin. And so what's happening there is it's this point right here on the axis. If we go 2 to the left, we're at the origin. If we flip it, we're already at the y value 0, so we don't need to flip up or down, right? We're just sort of stay fixed at that point. So going through there, right, totally makes sense, and that's consistent with what we had. If we fill in the rest of this, so if we take this, right, 2 to the left, so we're starting at -1, +2, so 2 to the left, and then we flip down, right? What's happening here is, generically, right, instead of going up and flat and down, if we flip that shape, it's going to go down and flat and up, and then the whole thing is shifted to the left. So we can kind of guess for our last point, not guess, but, so where are we? -3 and then down 2. 1, 2, 3, down 2. So starting here, 2 to the left, and then flip it. Our last value is going to be up here. We're sort of getting off of our chart a little bit. So our last leg is here. So this is, right, in blue, negative f of, in parentheses, x plus 2. I'll do one last shift. We'll do it in red, I suppose. And let's do, let's just do a vertical stretch. So we'll just multiply by 2. I'll squeeze it in down here. Let's do 2 times f of x. Right? So this should essentially double all of our y values. This is going to be, right, vertical stretch by 2. So again, our original, right, sort of is here and here, comes down, comes down. And so what's happening is we're going to double all of the y values. So it's going to sort of take this graph and it's going to stretch it out vertically. So let's start here, I suppose. So let's do 1, 2, 3 over and 2 down, 1, 2, 3 over, 2 down. So starting here, so this is down to -2. If I double that, right, the y value, it's going to now go down to -4, right? So multiplying this by 2. When I'm at 0, right, 2, 0, 0 times 2, right, 2 times the y isn't going to change it. So I actually have this point is still in the exact same position. If I'm at, +1, +2, if I multiply the y by 2, it's going to kick me up to 4. So this is going to go from here, times it by 2, goes up to 4. So what happens is the whole thing is getting really sort of stretched out. It's really sort of exaggerating these sort of vertical moves, right? Everything is getting sort of pulled and stretched out. This then, if I kind of fill in the blanks, this is going to come over. We're going to be going through the center again here, right? We're just sort of mirroring these same kind of moves. And then this, right, point comes down to here. And we're going to match it. Connect everything together straight as we can. Whoops. Right. So our new function, right, in red, 2 times f of x is this sort of stretched out version gets stretched that way. So that's 3 variations, right, based on this original graph. None of this is sort of necessarily coming from a table specifically, right? It's not something we know a formula for. We don't have a formula for the function. We're exclusively basing this off of just taking a graph and stretching it out.